Hi, here's the first set of the three problems, and I'm going to use integration to show you how to find probabilities. They're all normal random variable examples, and the first way I'm going to use integration in this worksheet. I'm going to do the normal table on the next sheet, and then I'm going to use Minitab. So I'll try to talk fast so these aren't really long. The length. Okay, so sending myself email. The length, okay, so underline. The length of an aluminum steel sheet is approximately normal. And you probably just heard my dog. She jumped off the couch. Normal with a mean of 75 centimeters and a standard deviation of 1 centimeter. Find the probability that you select one of these sheets, and it's between 74.5 and 75.8 centimeters. Okay, so first I know that x, I'm going to let x be the length of sheet. Okay, and we're told that it has, and that little squiggly, I'm just saying x has the shape of a normal distribution with mu equal to 75 and sigma equal to 1. Okay, the density function, I'm just going to type it out, is 1 divided by square root of 2 times pi times sigma, in this case is 1, times exponential function. You type exp, right? It's not e in maple, so exp negative x minus the mean squared, and I want to take that and divide it by 2 times sigma squared, and that should do it for me. This is defined for all real numbers, so let me make sure that I didn't make any mistakes in this. So I'll call this, oh no, those are my dogs. Let me go ahead, this is there, and I'm not sure, I mean, the way to tell if I have typed it in correctly, I'm just going to integrate this guy from negative infinity to infinity, and let's see if I get 1. If not, I have a mistake in the way I typed it in. Okay, good, so I know that I don't have any mistakes in my function, and now what I want to do, I want to find the probability that the sheet is between 74.5 and 75.8. So I'm just going to integrate this guy from 74.5 to 75.8. And I should get a probability, and it should be between 0 and 1. So here we are. There's my probability, and that problem's done. All the other ones are going to look very similar, so if you feel comfortable with that one, I'm just going to kind of repeat and do maybe a little variation on that. So down here, the scores on some dexterity test have a normal distribution. I didn't want to do that. Have a normal distribution. Let's underline that, with a mean of 12, standard deviation of 3. What's the probability that we randomly select, I don't know, a score from somebody and it's less than 14? Okay, so let's just do A first. I'm going to let X, I'm going to let S, but X equal dexterity scores, and they have this shape of a normal curve with the mean being 12 and sigma being 3. Okay, so we really just have the same density function we had above, except with mu is 12 and sigma is 3. So you know what I'm going to do? I'm just going to grab this guy up here and just change the mu and the sigma in it. So down here, let me see, here's sigma right there. I'm going to change it to 3. And there's mu right there. I'm going to change it to 12. And there's sigma right here. I'm going to change it to 3. I'm sure it's going to integrate to 1. What's the probability we grab an individual? Their score is less than 14. So I'm going to integrate f of x between x equals 0 to 14. I can't have a score less than 0. I'll probably get an IRF because I have integers in there. It's not going to do a numerical method. It'll try to pump out, yeah, see, it's trying to pump out an actual value. So let's just eval f that thing. Okay, so what does that look like? Maybe I could have drawn you a picture. Plot f of x from x equal, what was this score? It was 12 with 3. So, I don't know, let's just plot it from x equals 0 to, I don't know, 20. Let's just, so you can see what I'm doing. I'm just integrating this curve between, well, wasn't I integrating that curve for x's less than 14? So let's get a little bit better into view. So if I put a line at 14 right here, I'm just finding the probability up to 14, and that's pretty practical. It makes sense. Let me see, part B. Now I'm going to select 8 individuals are going to take the test. Okay. What's the probability that 4 or more will have a score less than 14? So we know the probability, P equals probability of score less than 14, and that's equal to 7474. So 0.7475. So P is a probability, I think I spelled that wrong, of score less than 14. So I'm going to let Y equal number of individuals out of 8 with score less than 14. What kind of random variable is Y? We have 8 people doing this test. Either they got a score less than 14, more than 14, so this is a binomial. So Y has the shape of a binomial curve with 8 trials and probability of success 0.7475. And I want to find the probability that 4 or more, so Y is greater than or equal to 4. Okay, so let me just type in here the probability mass function for Y. It's a binomial, so binomial 8 choose Y times 0.7475 raised to the Y times 1 minus 0.7475 raised to the 8 minus Y, right? And if I sum P of Y from Y equals 0 to 8, that's a support. I better get 1. Yeah, I did everything right. And I want to know the probability that 4 or more will score less than 14. So 4 or more would be 97153. Okay, so that one's done. Maybe I'll go ahead and save this so then I can post it for you later. One more problem. Okay, another normal random variable. Suppose that the IQ of a student at a certain college is normally distributed, mean 110, so x equal IQ, shape of a normal with a mean of 110 and a sigma of 20. Okay, determine the 95th percentile. So I want the value, I want the IQ that leaves 95%. Let me draw you a plot. First I gotta go. Let's do the same thing we did before, cut and paste this guy, huh? Yeah, let's just, that will be the quickest way to do it. So here he is, standard deviation 20, mean 110, standard deviation 20. Okay, so let's just plot f of x from x equal, the mean is 110, 20, 20, 40. Let's go from 70 to 150. Okay, I think that's like 2 standard deviations, right? So there's my graph. Let me do a little bit more to this. Let's take it down to 50 up to 170. There's a little bit better. I want to find the value. I mean, somewhere, maybe even further, I want to find that value that leaves, if I was in this picture, leaves 95% area to the left, 5% to the right. Maybe even, well, let's go out to 180. Yeah, I mean, it's got to be out here past 160. So what I'm going to do is I'm going to solve an equation. So solve, if I integrate f of x from x equal, let's say c to infinity, I want to find the value c that leaves 5% in the right tail. So what do I have wrong in here? Maybe I don't need two of those? Okay. It's probably going to spit out some imaginary numbers. It does. So bunch of crap, right? But the one that works is 142. That seems... Really? Well, I guess so. I mean, I guess I could check it, right? If I integrate from, let's say, 0 to 142.9, I should get 95%. Oops, I graphed it. Great, let's integrate it. Oh, 95. So I guess it's 42.897 is the 95th percentile. Okay, that's it. I'm going to close this guy up and do this all over again with a z-table.